Hey, how's it going, guys? So today I'm going to share my simple, easy solution to the LeetCode 323 question: number of connected components in a undirected graph. So the question is fairly easy to understand. So given n nodes labeled from 0 to n minus 1 and a list of undirected edges, write a function to find the number of connected components in an undirected graph. So if you're given 4 nodes, basically 0, 1, 2, 3, 4, and edges. So basically, you know that 0 connect to 1, and 1 connected to 2, and 3 connected to 4, and you have to output the number of connected components. So basically, you can see that 0, 1, 2 is connected, and 3, 4 aren't connected, but they are separate by themselves. So we output 2. And if your edge list is 0, 1, 1, 2, 2, 3, 3, and 4, you can see that all of them are connected, so your output is 1. Basically, yeah, you have to output the number of connected components. And I know that this question can be done using union find, BFS, DFS, but I just think the BFS is very easy to understand. So I'm going to share the BFS solution. So basically the algorithm is to write a BFS helper function to traverse all the nodes in a connected component and label them as seen. So for example, when I see 0, I mark it as seen, and I see 1, I mark it as seen, and I see 2, I mark as seen. So my BFS basically traverse the connected components and mark the nodes as seen. And then in my main function, I just to call the BFS, and the number of time I call BFS is the number of connected components. For example, when I go to 0, I mark it as seen. 1, I mark it as seen. 2, I mark it as seen. At 3, let me share the code, and maybe you can understand it better. So for example, in your main function, you have a scene set, and you have a count, and your output the count. So for node in range n, so if our n is 5, range n is 0, 1, 2, 4, 0, 1, 2, 3, 4. If node is not in scene, we will trigger the BFS. So for example, 0 is not in scene, we'll trigger the BFS. And what the BFS is doing is, as we said before, just mark the connected components as seen. So for example, 1 will be marked as seen, 2 will be marked as seen, and the BFS will stop. And then so when I go to when I finish node 0, I go to node 1, because in the BFS I already marked 1 as seen. So you will not jump into this if statement. So I will go to node 2, and node 2 is also in the scene, so you will not go into this if statement. And I will go to node 3. Node 3 is not in scene, so I will trigger the BFS, and the number of connected component is incremented by 1. And also in the BFS of the 3 and 4, the 4 will be marked as seen. So when I go to node 4 here, you will not go into this loop because it's already in sync. And finally, I will just return 2 as the number of connected components. Okay, so and the BFS function is just like a template for BFS. If you're not familiar with the template for BFS, basically using a queue, then you should probably go back and learn more about BFS template. So basically, you create a double-ended queue, and then you append your node into your queue, and you mark it as seen. And while queue is not empty, you pop the leftmost from the queue. And for the neighbors, if it's not in scene, you also add it to scene and append it to queue. Yeah, again, this is just like a template for BFS. If you're not familiar with the code here, you should maybe watch more tutorials about BFS traversal. And what we do here is because we are only given an edge list, and it's easier if we have a graph. So that's why I create a dictionary of dictionary of default list. So basically, this will look like this. It's I think it's called adjacency